February 14th, 2023. Somewhere in western Ukraine. The concrete stairs descend into darkness, each step echoing against walls that haven't seen daylight in decades. Senior Lieutenant Dmytro Kovalenko steadies himself against the cold metal railing, his breath forming clouds in the frigid air. Behind him, two technicians, Oleksandr and Yuriy, carry a battered aluminum case between them, grunting with the effort. The basement door groans open, revealing a space that was never meant to be a weapons laboratory. Fluorescent tubes flicker to life, illuminating what was once a Soviet-era civil defense shelter. Now it's something else entirely. Workbenches line the walls, cluttered with oscilloscopes, soldering irons, and laptop computers displaying lines of code. In the center of the room, lying on reinforced steel supports like a patient on an operating table, rests a monster from another era. An S-200 surface-to-air missile. 23 feet of oxidized metal and Cold War engineering. Kovalenko approaches the missile slowly, running his hand along its scarred surface. The S-200 NATO designation, SA-5 Gammon, was designed in the 1,960 seconds to shoot down American bombers at high altitude. This particular specimen is older than he is, pulled from a storage depot that the Russian military had written off as worthless decades ago. They were wrong. GPS module arrived, Oleksandr announces, setting the case on the nearest workbench. He's 32, a former aerospace engineer from Kharkiv, who watched Russian artillery destroy his university. His hands shake slightly as he opens the case, not from fear, but from exhaustion. They've been working 18-hour shifts for 3 weeks. Inside the case, nestled in foam padding, sits a civilian GPS guidance kit. The kind of technology you could order online for a few $1,000s. The kind of technology that's about to turn a relic into a precision weapon. Yuriy, the youngest of the team at 26, pulls up a chair and opens his laptop. The inertial navigation system is completely shot, he says, scrolling through diagnostic data. But the rocket motor is solid, fuel's stable. If we can replace the guidance section entirely... We're not replacing it, Kovalenko interrupts. We're augmenting it. He moves to a whiteboard covered in calculations and crude diagrams. The S-200 was designed to receive radio guidance from ground stations. We're going to hijack that system, feed it GPS coordinates instead. The concept is audacious, borderline insane. The S-200 was never meant to strike ground targets. Its guidance system was designed to track aircraft, to follow radar returns and radio commands. Converting it into a surface-to-surface missile means rewriting decades-old Soviet code, fabricating new interface hardware, and somehow convincing a weapon system designed to go up to come down precisely, on target, hundreds of kilometers away. Outside, the distant rumble of artillery reminds them why they're here. The war has been raging for nearly a year. Ukraine's Western allies have provided weapons, but always with restrictions, always with range limitations. The HIMARS rockets can reach 90 kilometers. The Storm Shadow missiles, when they arrive, might manage 300, but Crimea, occupied Crimea, where Russian command centers and logistics hubs operate with impunity, sits just beyond reach. Until now. Kovalenko turns to his team. The S-200 has a range of 300 kilometers in its original configuration. As a surface-to-surface weapon, accounting for the ballistic trajectory, we're looking at 250, maybe 300 if we optimize the flight profile. He taps the whiteboard. That puts Sevastopol in range. That puts the Kerch Bridge in range. Oleksandr is already unpacking the GPS module, his engineer's mind racing through the integration challenges. We'll need to fabricate a mounting bracket, run power from the missile's internal bus, and create a translator unit to convert GPS data into guidance commands the S-200 can understand. How long? Kovalenko asks. For the first prototype? 2 weeks, maybe 3. You have one. The fluorescent lights hum overhead. Somewhere above them, Ukraine fights for its survival with whatever weapons it can beg, borrow, or build. Down here, in a basement that smells of machine oil and desperation, 3 men are about to prove that innovation doesn't require billion-dollar budgets or state-of-the-art facilities. It requires necessity, and Ukraine has that in abundance. Yuri's fingers fly across his keyboard, beginning the painstaking process of reverse engineering Soviet guidance protocols. Oleksandr measures the GPS module against the missile's guidance section, already sketching adapter designs. Kovalenko stands back, watching his team work, knowing that what they're attempting has never been done before. The S-200 lies silent on its supports, waiting to be reborn. Oleksandr's first challenge is physical integration. The GPS module, a compact unit designed for commercial drones, needs to communicate with a guidance system built when transistors were still cutting-edge technology. He fabricates an interface box from aluminum sheet metal, cutting and bending it by hand in the corner of the basement. Inside, he mounts a microcontroller, a voltage regulator, and a maze of hand-soldered connections that would make any electronics engineer wince. It's not pretty, he admits, holding up the device for Kovalenko's inspection, but it'll work. Will it survive launch? Kovalenko asks. The S-200's rocket motor produces forces that would tear apart most civilian electronics. Oleksandr nods toward a foam-lined box on the workbench. Shock mounting, same principle as artillery fuses. The GPS module sits on dampeners. The interface box is potted in epoxy. It should handle 20 Gs, maybe more. Should. The word hangs in the air like smoke. Yuri's challenge is more abstract but equally critical. The S-200's guidance computer, if you can call it that, operates on principles from the 1960 seconds. It expects continuous radio commands from a ground station, corrections transmitted at specific frequencies in specific formats. He needs to make it believe those commands are coming from its original Soviet hardware when they're actually being generated by a GPS receiver and a microcontroller running code he's writing from scratch. The missile expects position updates every 2 seconds, Yuriy explains, his eyes red from staring at hex dumps of ancient firmware. The radio receiver outputs analog voltage levels corresponding to azimuth and elevation corrections. We're essentially spoofing those voltages based on GPS coordinates. He pulls up a simulation on his laptop. A red line traces the missile's intended path, a ballistic arc rising to 50,000 feet before descending toward a target point in Crimea. Green dots mark GPS waypoints. The tricky part is the terminal phase. The S-200 was designed to detonate near aircraft, not impact ground targets. We need to keep it stable all the way to impact. Kovalenko leans over the screen. Can you do it? Ask me again in 3 days. Those 3 days blur together. The basement becomes their entire world, a realm of solder smoke, energy drinks, and the constant clatter of keyboards. They sleep in shifts on cots pushed against the wall. Meals arrive via a rotating cast of volunteers who know better than to ask questions about the missile in the basement. On the 4th day, they conduct their first integration test. The GPS module, now mounted in its shock-resistant housing, connects to the interface box. The interface box connects to the S-200's guidance section via a bundle of cables that Oleksandr has painstakingly spliced into the missile's original wiring harness. Yuri's laptop serves as the command station, running software that can input target coordinates and monitor the missile's status. Power on, Oleksandr announces. The missile's internal systems wake up with a series of clicks and whirs. Decades-old gyroscopes spin up. The guidance computer, its circuits etched in a Soviet factory before any of them were born, begins its startup sequence. Yuriy types rapidly, feeding it coordinates. Sevastopol Harbour, the naval headquarters building. His fingers pause over the enter key. Here goes nothing. He presses it. For 3 seconds, nothing happens. Then the missile's control surfaces the fins, designed to steer it through thin air. At Mach 4, begin to move. Tiny adjustments, responding to commands that the guidance computer believes are coming from a ground radar station, but are actually being generated by a GPS receiver calculating the path to a target 270 kilometers away. It's tracking, Yuriy breathes. It's actually tracking. Oleksandr grins, the first genuine smile Kovalenko has seen from him in weeks. Change the target, see if it responds. Yuriy inputs new coordinates, the Kerch Bridge, the vital supply line connecting Crimea to Russia. The control surfaces adjust smoothly, reorienting for the new trajectory. Gentlemen, Kovalenko says quietly, I think we just invented a new weapon system. But invention is only the first step. The modified S-200 needs to be tested. And testing means launching a 23-foot missile carrying hundreds of kilograms of high explosive. It means finding a launch site, transporting the weapon, and hoping that their basement engineering holds together under the brutal physics of rocket propulsion. It means risk. The launch site is chosen carefully, a clearing in a forest, far from civilian areas, with sight lines that allow the missile to clear the trees before its motor reaches full thrust. A military truck delivers the S-200 under cover of darkness, along with a improvised launch rail fabricated from steel I-beams. The missile is erected vertically, its nose pointed at the stars. Kovalenko stands 50 meters away, behind a concrete barrier, watching his team make final preparations. Oleksandr checks connections one last time. Yuriy's laptop, now connected via a long cable, displays the pre-launch checklist. Target coordinates: an abandoned industrial complex in Ukrainian-controlled territory, cleared for weapons testing. All systems green, Yuriy reports. GPS lock acquired. Guidance computer accepting commands. Kovalenko picks up the radio. All personnel fall back to safe positions. Launch in 60 seconds. The forest grows quiet. Even the birds seem to sense what's coming. 30 seconds. Kovalenko's hand hovers over the launch button, a simple switch wired to the missile's ignition system. Years of military training wore with the knowledge that this weapon was built in a basement by 3 men who had no blueprint, no manual, no guarantee of success. 10 seconds. He presses the button. Then the S-200's rocket motor ignites with a roar that shakes the earth. Flame erupts from the base, a column of white-hot exhaust that turns night into day. The missile trembles on its launch rail, building thrust, and then suddenly, violently, it rises. The acceleration is brutal. The S-200 clears the tree line in seconds, climbing on a pillar of fire that illuminates the forest canopy. Kovalenko watches through binoculars as the missile arcs eastward, its motor burning bright against the darkness. The roar fades to a distant thunder, then to silence. Telemetry, Kovalenko shouts over the ringing in his ears. Yuriy's eyes are locked on his laptop screen. GPS signal strong, guidance system responding. Altitude 12,000 meters and climbing. It's following the programmed trajectory. They wait. The missile is beyond visual range now, somewhere over the Ukrainian countryside, climbing toward the apex of its ballistic arc. If the guidance system fails, if the GPS module shakes loose, if any one of 1,000 things goes wrong, 200 kilograms of high explosive will fall randomly from the sky. Apogee reached, Yuriy reports. Beginning terminal descent, control surfaces responding. It's working. It's actually working. 18 minutes after launch, Yuriy's laptop displays a final telemetry burst, then nothing. The GPS signal has ceased either from impact or system failure. They won't know which until reconnaissance confirms. The confirmation comes 6 hours later, delivered by a drone operator who flew over the target site at dawn. The abandoned industrial complex has a new feature. A crater 20 meters wide, precisely centered on the coordinates they programmed. The S-200 struck within 15 meters of its intended target. A weapon designed in the 1,960 seconds to shoot down bombers, modified in a basement with commercial GPS technology, has just demonstrated precision strike capability. March 8, 2023. Sevastopol, Crimea. The Russian naval officer doesn't hear the missile coming. No one does. The S-200 descends from 50,000 feet at supersonic speed, its guidance system making microscopic adjustments to keep it on target. There's no warning, no air raid siren, no time to react. The warhead detonates in the courtyard of the Naval Headquarters building at 0347 hours local time. The explosion shatters windows for 3 blocks, sets vehicles ablaze, and sends a mushroom cloud of smoke rising over the harbour. Russian personnel scramble in confusion. Sevastopol is supposed to be beyond the range of Ukrainian weapons, protected by distance and air defence systems. But the S-200 didn't come from a Ukrainian aircraft. It came from a launch site 270 kilometers away, flying too high and too fast for the air defences to intercept. By the time Russian radar detected the incoming missile, it was already in its terminal dive. In the basement workshop, Kovalenko receives the news via encrypted message. The strike was successful. Damage assessment indicates the headquarters building is severely damaged, with multiple casualties among Russian naval command staff. More importantly, the Russians don't understand what hit them. Their initial reports speculate about cruise missiles, about Western weapon systems, about anything except the truth. The truth is that 3 Ukrainian engineers just changed the calculus of the war. How many more can we convert? Kovalenko asks. Oleksandr consults his notes. We identified 17 S-200 missiles in storage depots across Ukraine. Most are in similar condition to the first one, old but functional. With the process refined, we can probably convert 1 every 3 to 4 days. Then we start immediately, Kovalenko says. Crimea needs to understand that occupation has a price. Over the following months, the basement workshop becomes a production line. Each S-200 receives the same modifications: GPS guidance, shock-mounted electronics, reprogrammed targeting systems. The team expands other engineers, other technicians, all working in secrecy, all driven by the same desperate innovation. The strikes continue. A Russian ammunition depot near Jankoy erupts in a fireball visible from space. The Kerch Bridge, that symbol of Russian control over Crimea, suffers damage to its railway section when an S-200 impacts the approach span. Each strike extends further into occupied territory, each one demonstrating that Ukraine's reach is longer than Moscow believed possible. The Russians adapt, eventually. Air defences are reinforced, command centres are relocated. But the psychological impact remains. Nowhere in Crimea is truly safe. The weapons that were supposed to defend Soviet airspace in a war that never came have found new purpose, striking back at the invaders who thought distance would protect them. In Western military circles, analysts study the Ukrainian modifications with a mixture of admiration and disbelief. The conversion of air defense missiles into precision strike weapons isn't unprecedented. Israel did something similar with their own systems, but never under these conditions. Never in basements, with commercial technology, while under active threat of bombardment. Kovalenko stands in the workshop one evening, watching his team prepare another S-200 for conversion. The basement that once seemed cramped now feels almost familiar, a place where impossibility becomes routine. He thinks about the engineers who designed these missiles 60 years ago, Soviet technicians who never imagined their creations would be used this way by these people in this war. "You know what's funny?" Oleksandr says, appearing at his shoulder. "The S-200 was designed to defend against American B-52 bombers. Now we're using it to strike Russian targets. History has a sense of irony." Kovalenko nods. "The Cold War ended, but its weapons didn't. We're just repurposing them." "Repurposing," Oleksandr repeats, smiling. "That's one word for it. Outside, the war continues. But down here, in a basement that smells of solder and determination, Ukrainian engineers are proving that innovation doesn't require unlimited resources or perfect conditions. It requires necessity, ingenuity, and the willingness to turn relics into weapons, obsolescence into opportunity. The S-200 on the workbench awaits its transformation, another Cold War giant about to be reborn with a new purpose." Somewhere in Crimea, Russian officers sleep uneasily, knowing that the next strike could come at any moment from a weapon system they thought was long dead. They were wrong about that, too.